Today we're going to work with inverse trig function. So an inverse trig function is used to find the measure of an angle. Alright, so before we go on with this, I just want to point out that an inverse of a trig function is different than a reciprocal of a trig function. So the reciprocal of cosine was, or is, secant. The reciprocal of sine is cosecant, and the reciprocal of tangent is cotangent. That is not what we're doing today. Today we're going to do the inverse. So we're actually going to be looking for missing angles. So I'm going to erase that. I don't need that anymore. Let's go ahead and try this. Alright, the first example says find the measure of angle P. Here's angle P. I'm going to call it theta. I'm going to label the side that has an 18 on it as the opposite side, and the side that has an 11 the adjacent. So which trig function uses opposite and adjacent? Remember, SOHCAHTOA. What uses opposite and adjacent? That would be tangent. So tangent of theta is equal to the opposite over the adjacent. Alright, here's where the calculator comes in. Before when we were doing these, we actually had an angle measurement right there, so we could type tan 45. But we can't do that this time, so we are going to use the inverse of tan. Arctan is also what it's called. So arctangent looks like this. Tan with that little negative 1 exponent. You should have done this back in geometry, so this shouldn't look brand new to you. Then you're going to type in 18 over 11. So here I want you to get out your calculator, and I want you to type with me just to make sure you can get this. When you type that into your calculator, you should get that that is equal to 58.5704. The directions are telling us to round to the nearest tenth, so 58.6 degrees. Alright, let's try another one. Next one is asking us to find the measure of angle U. So I'm going to label angle U with a theta. There's the angle we're looking for. So 28 is across from the right angle. That would be the hypotenuse. 19 is opposite from theta. So we have O and H. Sine uses O and H. Set up my trig function here. Sine of theta is equal to the opposite side over the hypotenuse. Since I don't know what the angle is, I'm going to use the inverse of sine, or arc sine. Sine -1 is what it looks like there. 19 over 28. At this point, I want you to get your calculator out. I guess I didn't really tell you how to use it before. This is where you want to use your second button, or your shift. And you should see it on your calculator with the sign, the little -1. Alright, you type this into the calculator. You will get 42.7321. If you're not getting that, you might be in the wrong mode, or just let me know in class and I can help you. Theta, rounded to the nearest tenth, would be 42.7 degrees. Alright, let's try some more here. You will notice that I gave you some extra information on these. With this, I'm pretty much telling you which quadrant we're going to be working in. Please notice too, my little oopsie-daisy over there, number 5 should be the sine of theta is equal to positive 0.79. Alright, so change that. I can't really change that little negative on here without making a big blob. Okay, so we'll get to that in just a minute. Let's look at number 3. Number 3 says the cosine of theta is equal to 0.4. So I need to know what theta is. So I will do cosine, the arc of cosine, or the inverse of cosine. of 0.4. Use your calculator. You type that in and you're going to get 66.4 degrees. Now, that's not really the answer because remember I told you which quadrant we're working in. So I want to be between 270 and 360 degrees. Make your chart here. 270 degrees is down there, 360 degrees is here. So that puts us in the fourth quadrant. Remember, cosine can be positive in that quadrant because cosine is just my x value. My y value would be negative. And what I told you really here is what would be the reference angle. So this angle right there is 66.4 degrees, which means I need to know, I'm going back, remember an angle always starts on the positive x-axis and goes all the way around. So that's actually the angle that I'm looking for. So we're kind of undoing the reference angle here. So in order to get that big blue angle that I made, I would have to do 360 minus 66.4 to figure out that that angle is 293.6 degrees. Because again, in the directions I said to round to the nearest tenth. All right, let's look at another one. Tangent. I'm going to get the calculator out and do arctan of 4.7. Do notice that tangent is positive here. Tangent will only be positive in either the first or the third quadrant because remember it's y divided by x, sine divided by cosine. So either x and y have to be positive or x and y have to be negative. So I'm going to draw my xy axis. Notice I did tell you that I want this angle to be between 180 degrees and 270 degrees. So that puts me in this quadrant. All right? When I typed this into the calculator, I got 77.9885. So pretty much I got 78.0 degrees. All right, again, that's just a reference angle. If I would have been in the first quadrant, I would have been done. My answer is 78, but I'm telling you that I want to work in this third quadrant. So this angle right there is 78.0 degrees, which means the actual angle always has to start on the positive x-axis and go all the way to there. In order to find that, I would do 180 plus 78.0, and that's going to give me 258.0 degrees. All right, another way to kind of check too is, does your answer fit in between 180 and 270? 258? Yes, it does. If you went back to number 3, is 293 between 270 and 360? Yes. If not, that's one way to kind of check that you messed up. All right, let's take a look at another one here. Remember, this is one that we changed. So I'm telling you that sine of theta is positive 0.79. So, oops, hang on. First thing I want to do is do arc sine, the inverse of sine, 0.79. Type that into the calculator, and it's going to tell you 52.1855. So 52.2. Oops, I just wrote 0.5. I'm losing it, guys. All right, so I'm going to graph my xy axis here. Again, look at what I'm asking you, where I'm asking you to put this. I want it to be between 0 and 90 degrees. So that's me telling you, put it in the first quadrant. So here is my 52.2 degrees. Remember, an angle always starts there and ends where I had the angle. So technically this isn't a reference angle this time. This is just the answer. The answer is 52.2 degrees. I did it again. What is wrong with me? All right, there we go. Now, let me just point out here too. If I wanted sine, you know, my little oopsie daisy here, if I really wanted sine to be negative, I would have had to have a negative y value. So it's kind of like a good little point here. I'll do this in red. If I really wanted sine to be negative, I would have to have my y value be negative, so I'd have to be in either the third or the fourth quadrant. But since I told you the first quadrant here, it was just an impossible problem, the way it was set up. All right, let's try some more. All right, surprise! Here's an extra problem. So this is not on your notes, so go ahead and write this somewhere. If you flip over your 9.4 notes, it should be blank on the back, or you should have some room under number 7, so in that bottom right corner. But so this time we're doing cosine of theta is equal to negative 0.87. So I want it to be negative this time. I'm happy about that negative. All right, and I'm telling you that I want to be between 180 and 270. So here's 180 degrees and here's 270. So I want you to be in the third quadrant. So let's figure out what this angle actually is. I've got cosine, arc cosine, because I'm trying to figure out the angle, of negative 0.87. Type that into the calculator and you should get 150.45 or 150.5. I'm going to draw the angle here because that's what I want. Now, there is no way that this angle right there can be 150 degrees. Remember we said a reference angle is always acute. This is not acute. So in order to get an acute angle, I am going to take 180 and subtract 150.5. I'm just going to round that to 0.5. When I do that, I get 29.5. So this angle here is really 29.5 degrees. Yikes. So that angle is 29.5. So that's the reference angle. I know that was kind of weird. It's kind of tricky here. But we can't have a reference angle that's bigger than what it can't be obtuse. All right, now, I know that I want to end here. Remember, your angles always start on the positive x-axis. Go all the way around. So that's going to be the angle that I'm actually looking for. In order to do that, I'm going to have to do 180 plus 29.5 to give me 209.5. So I wanted to make sure we added that on because that was kind of a tricky problem. All right, a few more problems to do. Let's go on.